we're now going to go over the programming basics. First, we're going to create a program. We first press select to go to the program select page, and we press create, which would be F2. Now, when you create a program, you first got to give it a name. At this time, I'm going to tell you a bit about typing with FANUC. It's not the easiest thing to get used to, but your F key suddenly becomes the main method of typing. By default, it'll usually bring up words. So if you pressed F1, it typed the word style for you. You have the backspace right here to clear that if you want. Most of the time, what you want will not be listed here. You can always customize these at a later time. But if you go down to uppercase right here, you'll have the letters. And this types just like an old school phone where you just hit it multiple times. So if we want to call it training, we press this key twice for the T, press this a few times for R, A, I, N, F. I did not quite type as I wish, so I pressed the backspace. Press F2 a few times there. Yeah, training right there. Now, with this, if you ever have some word which uses the same letters in the same area, such as bat, you would have to press the right arrow over in order to type that next letter. Now, when you're creating a program, there are certain things that can't be done. For instance, you cannot have a space in here. It will not accept lowercase letters even if you put them in. Some characters cannot be used as well. You can use underscore if you want, but no spaces. And numbers, of course, are allowed. So I deleted the rest of that. We have a program training. So I press enter to save it and put that in. Now the first thing we're going to do is we're going to create a position. Notice right here we have this arrow. If you press the next button, it'll display more options here. We'll go over these all in due time, but for now we're going to look for the point one. So if we press point, it'll bring up some options as to what type of point we'd like to create. For this one, I want to create a joint movement to a position that is fine. We'll go over all this stuff in a little bit. Right now, we just need to talk about creating a few points. So I've created this point here. I'm then going to switch the coordinate frame to world, hike up the speed, and move the robot a little bit. We're going to create 3 basic points. Alright, so I'm going to create another point. Because I'm holding shift, it's just going to do the last type of position I made. And then I'm going to go down and create another point. Alright, so I have 3 different points now. If I, however, wanted to change up one of these points, let's say this 3rd point here, I did not want it this low. I jog the robot up a little bit, stop it. I actually have to be on the position right here. Highlight the position you wish to change, hold shift, and press touch up. It'll say the position has been touched up on the teach pen. Because of this computer display, it does not display it like that. Now that we've got 3 positions taught, we're going to use the forward and backward commands to move through this program. Now when you put your cursor on the first line here and press forward, the robot will move to that position, and then it'll keep going through the program until it's finished. Now when you finish running a program, you'll get to the end and the program will stop and the cursor just goes back to the top of the program. If we go to step mode by pressing this button here, you'll see it indicated right here. Now whenever we press forward, the robot will go to a position and then stop. Then it'll go to the next position and stop. If at any time you ever want to go backwards, you can by pressing backwards. Pressing backwards will ignore all other code except for the position. When you have more complicated programs, for instance, if between lines 1 and 2 right here we were doing a lot of math, changing some registers and such, if we press backwards it would ignore that stuff and just go to that position right there. Now backwards does not always work, however, when you're using some jump labels and such, just due to the way FANUC has it set, so that you don't accidentally go to the wrong position when you were using some jump labels to move around in the program to determine which position you wanted to move to. So with this, we can move forward in the program as needed, and it works quite well. One thing to note is the type of motion we're doing. I'm going to move back to the first position right here. Now, to show this a little more clearly, I'm going to slow the robot down. We're going to talk about the position information. The position motion, actually. Right here we have this designated as a joint motion with this J. That means that the robot will move from the position it is at to this position here in a joint motion. So when we see this motion run, the robot does not have to follow a straight line when it goes to this next position there. If we want to force it to follow a straight line, we can go to this J right here, say choice, and change it to a linear motion. Now it will go in a linear line from position 1 to position 2. We're going to go backwards. Hold shift, backwards. Alright. Now, one thing to note, whenever you press the backwards command, it'll use the motion type of the position it was at, whereas when you press forward it uses the motion type of the position it's moving to. So since we were moving from position 2 to position 1 using backwards, it uses this position type. When you press forward, it's going to use the position type of the position it's actually moving to. So we press forward right here, and we move in a straight line. Now, joint motions are almost always the fastest way to go. Joint motions determine the joint positions at the starting point and at the end point, and it does all the math needed to determine what is the most efficient way to move from that point to the other point, so that all motors finish their motion at the same time and in the fastest way possible, while still abiding by the speed you have set. Linear motions, however, are restricted to a linear line and thus are not always as fast. It's usually not too big of a difference, but whenever possible, use joint motions. It'll keep the robot going fast. there are there are some rare cases where linear motions will actually go faster than joint, and that's usually when there's a lot of rotation involved and it's just able to handle it a little better. Still, I highly recommend, if you want speed, you keep with joint motions. The next important point about motions is how they end. Right here, all our motions are ending in a fine state. What fine means is it'll move to that position and stop. It'll move to position 1 and stop. Move to position 2 and stop. Move to position 3 and stop. We have the option, however, of adding a curve to this. We can go over to this fine option and change it to a continuous motion. So now it'll go to position 1 and stop, go to position 2 and continue with a CNT value of 100, and then go to position 3 as a fine motion, so it'll stop. Now the CNT right here will cause the robot to curve as it's going. If we go backwards to the previous point, position 1 right here, let's take ourselves out of step mode. When we use the CNT value, it will not reach this position here. It will instead curve away from it when it's approaching it. The way the CNT works is 0 means that it is basically a fine motion. It will decelerate all the way down to 0% its max speed right here and stop, whereas CNT 100 means the second it starts to decelerate to this position here, it'll continue towards the next motion instead. So a CNT of 50 means that once it's decelerated down to half of this speed right here, during its motion, it will actually start to curve. So I have adjusted the program a little bit to make all the motions linear, and just that one in the middle has a CNT value. I set up a simulation so that it'll run this program here, then another that is similar but with a CNT of 50, and then another program with a CNT of 0, so that you can see the difference. So when we run this program, so right here is the CNT 100 that will have the most curve right there. This next one is the CNT 50, and this last one here is the CNT 0, which is basically the same thing as a fine motion. So as you can see right here, it started to decelerate down to this position, so instead it started curving towards the next position. Right here at CNT 50, it was halfway through its deceleration and then started moving towards the other point instead. And CNT 0 went all the way to the point before moving on. So as you can see, the higher the CNT value, the more the curve. Another thing that can affect the curve from the CNT is the program speed right here. Now I've changed up the program so that this middle position here will have its speed go from 2000 millimeters per second to 1000 millimeters per second to 500 millimeters per second. So we'll run that one real quick. This is with a speed of 2000 millimeters per second. The CNT value is 100. The CNT value will be the same in all of these, but just the speed is changing to show how it's affecting it. Right there was the speed of 1,000 millimeters per second, and this is the speed of 500 millimeters per second. Because of this lower speed, the time at which it has, well, the position at which it has to start its deceleration changes. So with 2,000 millimeters per second, it needs a lot more time to decelerate so that it will actually reach that position. With 1,000 millimeters per second, it needs a little less time, and with 500 millimeters per second, it needs even less time. So these are the two factors that affect the CNT value. So if you want to make the robot more efficient and run a little faster, keep the speed high and the CNT value high. Now for certain areas you may need the CNT value or the speed lower, but just understand that these two factors right here affect that curve when you do this. The override speed up here, which is what the PLC will normally tell the robot to run at, does not affect cycle time. There is a default option in FANUC robotic arms, and that is prevalent in almost every robot I've seen, that makes it so that the override speed does not affect the CNT curve. Now, some other features about teaching the robot that you need to be aware of is how to actually stop the robot when you're moving. Right here, if we are running this program and moving the robot, we can let go of the shift button and the robot will glide to a stop. It'll just decelerate the motors and stop. Upon continuing, it'll try to jump back on the path if you have the robot constant path option. Otherwise, it'll just continue from where it was. The other alternative to stopping the robot is to let go of the dead man switch when you're moving. So if we're moving forward and we let go of the dead man, which for me, I don't have a dead man switch, I just have the teach pendant switch, it will immediately stop the robot as if it was an e-stop. So just kind of keep these in mind when you're teaching points and running through the motions, trying to avoid certain critical areas. One other thing we need to talk about is when you switch programs, like we were running this one right here, if we want to switch to a different program and run this one instead, we can't just start this program because it'll say it's already locked by another task. In ordering to abort the other task, the training program that we were running before, so that we can now run training 2, we have to press function, abort all. And now, when we reset the error, we can press shift forward, and we'll run that motion. The next thing we're going to talk about is how to add commands to your program. For instance, you'll usually have to turn on some digital outputs or change some registers. The way you do that is through this instruction tab right here. So we're going to go down to the bottom here, press instruction, and let's say for this program we wanted to add one to a register whenever we ran this. So we would say registers and registers plus equal. Now I already know all the registers are equal to 0, but we'll go over resetting the register a little later. For now, I want to set register 1 equal to register 1 plus 1. So that means at the end of this program, register 1 will add 1 to itself. Alright, so for this example, I'm going to pull up the registers right here. Register 1 is currently 0. So go over here, going to bump up the speed and press forward. So the program runs through it, and 1 is added to the register. When we run it again, another 1 is added to the register. Now let's say we wanted to get the robot to keep going in a loop. We wanted it to just keep doing this over and over. The way this works with FANUC is you have to use jump labels. FANUC code is not the most sophisticated one. There are not really any practical for loops that you can use. Almost everything is done through jump labels and if statements that result in jump labels if they are true. To insert a jump label here, we're going to press this edit command, which has some useful functions such as inserting a line, deleting lines, copying lines, finding certain things such as where registers are used in the code, replacing the registers, and renumbering, commenting, undo, and remark. For the most part, you'll use insert, delete, copy, undo, and remark. I'll show you a better way to use find on your computer at a later time. The undo button, while we're here, only undoes the last action. It does not have a history of changes you've made. So if you changed one thing recently, pressing undo will only undo that last one. It will not undo the last 2 actions or anything like that. Remarking will just remark out a line, so the code is still there, but it will not be wrong. For now though, we need the insert. So we're going to insert. How many lines do we want to insert? We're just going to say 1. We say instruction, label, and we want to use a label right here. Now, right here we need a landing spot for the program to jump to. So we're going to label this label 1, and at the end of the program we're going to jump to label 1. So now when we run the program, it will keep running in a loop. It will not stop until we have stopped the program, either through let and go shift or turning off the teach pendant here. You can see each time we finish the register gets added right there. Now let's say we wanted to reset the register at the beginning of the program. We would insert another line. We actually do not have to enter a 1. If it's just one space we wish to enter, we can just press enter. And right here, we're going to set the register equal to register 1 equal to 0. So we're going to start the program from the top here. Now when I press forward here, it'll actually give me a pop-up because we stopped the program midway and now we're asking it to start at a new line. So when we press forward, it'll say the cursor is on a different line from where the program paused, which was at line 3. Are you sure you want to run from this line? If I say no, it'll jump back to the line that it left off at. Now because we inserted some lines, it did not keep in mind that it was actually at this area right here. That's just something you need to be aware of. If you're inserting lines above, it keeps track of the line number, not the actual line of code. Now if we press yes, then it will allow us to continue from there. So we go back to the position 1 and we go with the loop. Register 1 was reset to 0, and now the counting starts over. Now for this, let's say we wanted to do a check in here. We wanted to find out if, and once we've gotten 10 of these motions here, we want to actually end the program. So instead of doing just a jump label here, we could have a conditional jump label. So we will change this to an if statement. So we're going to say if R1 does not equal, well actually if it's less than, if R1 is less than 10, then we want to jump to label 1. Otherwise, it'll go down in the code and it'll get to this end statement right there. So we're going to do the same thing we did before. I'm actually going to say, right here, I want to get to the top of the line anyways. Press forward, yes, forward again. So once register 1 equals 10, it will no longer be less than 10 and it will end the program. So after 10 loops here, it'll end. And then the program has stopped. Now let's say for some reason we wanted to no longer go to position 2, but we didn't want to permanently remove that. We just wanted to go between position 1 and 3, back and forth. What we could do is we could go to the edit commands and say remark. And so select the lines you want to remark or unremark, and we say remark. So now the path will just be from position 1 to position 3, because it will not run this line right here, because it is remarked out. So when we press shift and forward, it's just going to go back and forth. If we wanted to delete the line down here and just permanently get rid of it, we could go to the edit commands and press delete. It'll ask us which lines we want to delete. We can select multiple ones if we want. Let's say we just want to delete this one. We could do it just like that. Let's say that was an accident. We realized we didn't want to get rid of it. We could go to undo and press yes. And that will come back right there. Now, this is most of the basic commands you will have to do, except for inputs and outputs. We can set an output, so DO1 is equal to on at the end of this. Or we could change it so DO1 pulses on for 1 second at the end of this. You can put these instructions in there however you wish. You can adjust more than DO1. Any output you can adjust, such as group outputs or analog outputs if you want. You could also use digital inputs for our instructions right here. So we could say if DI1 is equal to on, then we want to jump to level 1. Otherwise, we'll end the program. There are more options with each of these, such as the option to have two different requirements for an if statement. We can say, instead of jump label, we can say and. So if we want, we can say if R1 is less than 5, as well as digital input 1. So if digital input 1 is on and R1 is less than 5, then we'll jump to label 1. If either of those is false, we'll go down to this line and then in the program. So these are just the basics of programming. Feel free to explore the instruction option here, and you can use waits if you want, where you could wait a certain amount of seconds, or you could wait until a certain condition is true, such as a digital input turning on. And press previous to cancel this. You could change the registers in other ways. You could subtract, multiply, divide, use the div function or the mod function. We're not going to cover those right now. And there's plenty of other options depending on what your code needs. The other aspect I want to cover before we end this basics is the miscellaneous section right here for remarking. It is highly recommended that you use remarks often to document your code. It makes it a lot easier for anyone to actually follow your code. So let's say right here we wanted to say the program was over and we'll turn on an output. Now I'm not going to use the F keys right here to type. I can actually go down here to the keyboard and type it in. When you press keyboard with the teach pendant, 1 will pop up for you. It's just as inconvenient as the F keys to type. But if you want certain characters, you have to use the keyboard. So program ends, turn on DA1. And then we can say DA1 is equal to on. Now remarks are not run in the program, they're just kind of skipped over for this. It'll still say it has run that line, but this produces no effect or delay in the program, so you're fine with putting in as many remarks as you need.